Now the particle chooses such a path. It moves like this and bends and chases p on the ground. On the in river it has v naught velocity, and on ground it has 2 v naught velocity related to river and 3 v naught due to ground. If it moves in this direction, that is 5 v naught. If it moves in this direction, it is v naught velocity, 3 v naught minus 2 v naught. Now the particle must move in such a way that it moves like that, not in this direction. The p point must be ahead of it. This is because the shorter the angle, the shorter the path here, and also this path will be traveled with a faster velocity, while if it moves with a larger theta, it moves larger distance with this small velocity, and then again a small velocity to move in this direction. So we make sure the particle is ahead of this boat or man. Now this looks like the refraction cases of light, critical angle case. The man moves with v naught velocity in this direction theta. Make a normal line. This is theta. V naught velocity in this medium. Particle moves with 5 v naught in this medium and chases p. Now this means sine for the fastest route, sine 90 degree divided by 5 v naught is equal to sine theta divided by the velocity in that medium v naught. This becomes sine theta is equal to 1 by 5. So this tells the angle at which the man should move, try to move with the vertical line. Now we got the solution of these questions very easily through Snell's law. We just need to know that the point must be ahead of it. So let's make a general equation for this. We need to make sure it not given. If v1 is the speed of river, then we need to make sure that v1 is greater or equal to maybe v, let's say vr is the, let's say this is vr river and vbr sine theta. This must be greater or equal to vbr sine theta. Why? Because if this is smaller, then the particle will stay behind and it needs to move backward with a slower velocity. So we will try to check if this condition holds true, then we can easily apply this Snell's law. Okay, now moving ahead, we have relative motions, some important chasing questions. Let's say there are two particles p1, p2, which are joined by a line at r distance, and their velocity makes this angle with this line. Then v radial means the distance, rate of change of distance of these 2 points. This is v radial, dr by dt, the distance between them, dr by dt, which can also be said as the v2 1, the velocity of 2 with respect to 1 parallel to the line. This is the v radial relative. It can be given by v2 cos theta 2 minus v1 cos theta 1, means we choose positive for increasing length. It increases length, and if it becomes bigger, the length decreases. Now chasing problem solution. Let's say there is a particle moving in a straight direction with v1 velocity, and there is another particle with v2 velocity, and v2 is greater than v1. It is must. This is length of separation between them with theta naught angle. Now, how do we solve? When do these 2 points meet? How to solve this? To solve this, we need two equations. First is the equation of distance traveled. This p1 particle travels v1 t naught distance. If t naught is the time of catching, then this particle reaches this distance in v1 t naught time, and this is the distance at L cos theta naught is the distance from this point to this, and the rest distance is traveled by the v2 in t naught time, which is given by v2 cos theta dt 0 to t naught. Here, if the particle is following this path, then the tangent makes theta angle with this line parallel to this v1's path. Then we can say that v2 cos theta is the velocity that makes it move parallel to v1, and the total distance of v1 t naught is equal to L cos theta naught, this distance plus the distance traveled by v2 in the direction parallel to it. Now, this integration is not easy. We do not know the relation between these, so we need another equation, which is through this dr by dt equation. We get dr by dt of 1 with respect to 2. The velocity of 1 we will write, since it is making a cos theta angle for any t time, we can say the radial velocity dr by dt is equal to v1 cos theta minus v2. This increases radial distance, and the radius changes from L to 0, from 0 to t naught time. This equation gives the value of cos theta dt. We can put this cos theta dt here and find the value of t naught. That's how these questions are solved. The important steps are to find an equation for letting these velocities, and second is the radial velocity distance of approach becomes L to 0, this one, and for any instant of time make a tangent to velocity and make a theta angle, and this theta angle is subtended here, and write radial velocity equation. That's how you solve these chasing questions. And we can also find omega or acceleration. In these cases, omega of 1 with respect to 2 can be found by using the radial relative velocity component perpendicular divided by the distance. At this instant, we can say the velocity of 1 relative to 2 is